Hey folks, good evening. We're going to get started here in about 2 minutes. Part 2 of the new Technician live stream, Ham Radio 2.0. All right, I'm just going to kind of kick it off right now. I show like 1 minute till, but that's okay. So thanks for joining us tonight. This is a special edition live stream. We did part 1 yesterday. It ended up lasting about an hour longer than we planned, but that's replayable on the channel. So if you've reached us tonight, either on the live stream or on Team Replay later on, this whole series, it'll be a 3-part series, yesterday, today, and tomorrow. And it is the new Technician question pool to get your very first amateur radio license, which is called Technician. It's part of the questions we went over yesterday. The questions pool is good from 2022 until 2026. So at the time of this recording, you've got 3 years that this question pool is good for. And last time we did this in 2020 during the COVID lockdowns, had a lot of people come by and watch this very detailed explanation of all the questions and answers, and since they updated last year, I definitely wanted to do this again. So we appreciate the Hearst Amateur Radio Club, w5hrc.org is their website, and we appreciate Chris, KD5HIY, for being the presenter/administrator of this. So I'm just going to kick it off to Chris tonight. We'll go over a couple of announcements here during break time sometime later in the show, so let's get him on there. What's up, man? How are you tonight? Unmute yourself. There you go.
There we go.
There you go.
Well, good evening, everybody. I hope everybody's doing well. Jason, doing well. Glad to see you again.
Yeah.
Happy to be here for sure.
Good deal. Yeah. And AA9PW is the website we talked about for free practice tests last night, and it is up and running. So AA9PW.com. You can take free practice tests, and there's a few others as well. I just kind of always like the format of that. So
yeah, same here. It generates tests, and then you go through the test, and then it grades it. Where some of the other ones will, as soon as you hit the cutoff as far as wrong answers, you're done. You don't get to go all the way through it. So I like the AA9PW pretty well too.
Yeah, for sure. All right, man. It is all yours. Take it away, and we'll see you at the break time.
Okay. Well, good evening, everybody. I'm glad to have you back. If you were with us yesterday, and like Jason said, I hope you've been doing some practice tests and maybe roughly 1/3 of the way through. So, if I just want to remind everybody, we are using the Technician class book. We saw this. Oops, sorry. Our lighting issues. Anyways, we're using the Gordon
screen.
West Technician book. And just as a reminder, you do have to study this book. This course is just a supplemental to the book. So if you don't study the book, you may find it difficult to get through the test. So use these 2 resources, and I think you will do well. So let me get going with the actual slides here. There we go. Okay. All right. So there is the book that, again, I was telling you about. So this class brought by Jason, Ham Radio 2.0, and then myself also. So let's get going. I do have a lot of information to cover, and so time is critical. Okay, so we're going to start with talking about amateur radios and space. And so a radio station that's located more than 50 kilometers above the Earth is considered a space station according to the FCC's Part 97. That's a space station. So this is a picture of an astronaut just kind of floating around up there. And the International Space Station is a big ham radio station. You can talk to them, which is a pretty neat thing to do. I haven't done it myself, but I know a lot of people have. So it's a lot of fun, and it's a skill to definitely learn. So any amateur radio operator holding a technician class license or higher may make contact with the ISS. It's a combination of using 2 meter and 70 centimeter, doing what we call cross banding to listen and talk. You listen on one band and you talk on another. And so you'll hear it referred to as a LEO or LEO. The initials LEO tell you that the satellite or the space station is in low Earth orbit there. And so if you take a look at the little graphic there, it'll kind of explain how low Earth orbit or the high Earth orbit, I think is what it's called. So if you want to track the International Space Station, there's certain ways that you can do that. There are some maps online that will show the position of the satellite or the International Space Station, the time, azimuth, and the elevation of the start, as well as the maximum altitude and the end pass. So it will actually show you where in the sky to look, where you can see the whatever it is that you're trying to contact. And also you can get the frequencies of the satellite transmission, including the Doppler effect. You do have to account for that, so you can get the effects of the Doppler shift. All three of these are correct. The computer programs that you find online or that you can download where you are able to track these satellites and see its footprint to make contact, they're called the Keplerian elements. Keplerian elements. And the sole purpose of the Keplerian elements programs are to tell you where satellites or space stations or any number of things can be found in relation to where you are. A satellite beacon, just like on Earth, it's a transmission from satellite that contains status information. Oftentimes, it would be a Morse code or a CW beacon. Modes of transmission commonly used by amateur radio satellites. Sorry about that. Sideband, FM, CW, or data. And so you can kind of see what an amateur satellite. We do have amateur radio satellites that were made by amateurs and actually sent up that you can make contact with. So anyone who can receive the telemetry signal may receive the telemetry signal. But as we said yesterday, telemetry and command and control are a couple of things that may be encrypted to kind of protect the ability to control. So depending on the satellite, you may or may not be able to actually decode the telemetry or the command and control information. Usually, if it is in just clear audio, you'll find health and status of the satellite. What are the batteries? How are the solar panels? And then also the rotation of the satellite and like how fast it's actually spinning, because it's not going to just be stationary. It's actually going to be rotating in a circle. One of the things that is common to hear whenever you're doing satellites is you'll hear like a spin fade. So as the satellite spins, the antennas are pointing away from you. Then they're in a circular motion. So you will hear a fading and then the signal coming back and it's usually relatively quick. So an observed change in the signal frequency caused by the relative motion between the satellite and the Earth. It's called the Doppler shift. It's just like if you are standing on the side of a road and you hear a fire truck coming towards you, and it's going to be a higher pitch, and as it's going past you, it's going to be a lower pitch. You do have to observe the Doppler shift in order to access a satellite or the ISS. Some radios will do this for you, and some of them you just have to manually tick the dial to stay on frequency, and that can be a trick, but it's a fun thing to give it a try and see. I've seen it done, but I've never done it myself. So a good way to judge whether your uplink power is neither too low nor too high is your signal strength on the downlink should be about the same as the beacon itself. So your transmission should be about the same as what you're actually hearing as far as what the satellite hears. The impact of using too much effective radiated power or power coming off your antenna on a satellite's uplink is you may actually be blocking other users. You may be overloading the receiver if you use too much power. If you use 1500 watts, you may completely overwhelm the receiver on the radio, and for a period of time, you may have what we call desensed or desensitized that receiver, and the receiver can't hear anybody for a temporary amount of time. So use only what you need in order to prevent you from just completely blowing the receiver away. So a satellite operating in what we call UV mode means the uplink, which you are actually talking to the satellite on, is going to be 70 centimeters, and then you're going to listen on the 2 meter band. And so some of these are some of the sub bands here. It will give you can find all the information for a specific satellite in the Keplerian application or online, just for general documentation of what's going on with the satellite itself. So some questions. What is the FC? Let's see. This is FCC Part 97. Excuse me. What is the FCC Part 97 definition of a space station? We discussed that that's going to be any station, even if it's a balloon that can get up that high, that would be considered a space station. Which amateurs may contact the International Space Station on the VHF bands? So this is going to be any amateur holding a technician class or higher. So why do we say any amateur holding a technician class or higher? Because back in the day, years ago when we had like the novice class license, when the FCC overhauled the actual classes and we went down to 3, there were some people who still held novice, and they got to keep that novice, so they cannot actually contact the International Space Station. They don't have enough privileges, but a technician class or higher can. So that's why we say if you hold a technician class or higher license, you can. What is an LEO satellite? Is that going to be a sun synchronous satellite, a high elliptical orbit satellite, a satellite in low energy operation mode, or a satellite in low Earth orbit? So that's going to be satellite in low Earth orbit. LEO is what that is an easy way to remember that. Which of the following are provided by satellite tracking programs? Maps showing real-time position of the satellite, track over Earth, the time, azimuth, and elevation of the start, maximum altitude, and end pass, or the apparent frequency of the satellite transmission, including its Doppler shift, or is that going to be all of those? The answer to this one is actually going to be all of them. It's going to be all 3 of those. You'll get all that information from a Keplerian Elements application, which you can download or you can use. They are online on the internet also. If you just Google or DuckDuckGo them or whatever it is that you might do. Which of the following inputs to a satellite? Which of the following are inputs to the satellite tracking program? Satellite transmitted power, Keplerian elements, the last observed time of 0 Doppler shift, or all of these answers are correct. Said it before, the Keplerian elements is the information, and the program will display those in a usable format to you. So what is a satellite beacon. The primary transmit antenna on the satellite, an indicator light that shows where to point your antenna, a reflective surface on the satellite, or a transmission from the satellite that contains status information. It's going to be D, transmission from the satellite that contains the status information. That can be sideband, just battery's okay, or it can be CW, or whatever the repeater owner, the satellite owner wants to actually relay. So what mode of transmission is commonly used by amateur radio satellites? A, single sideband, FM, CW, and data, or all of these choices are correct. You will find it in all three of these modes, depending on the satellite. Who may receive telemetry from a space station? Anyone, a licensed radio amateur with transmitter equipped for interrogating the satellite, a licensed radio amateur who has been certified by the protocol developer, a licensed radio amateur who has registered for access code from AMSAT. It's actually going to be anyone. Anyone can listen to anything if you have the proper hardware. So anyone can listen to the telemetry if you would like, even if you don't have an amateur radio license. What telemetry information is typically transmitted by satellite beacons? Signal strength of received signals, time of day, accurate to plus or minus 1 second, or health and status of the satellite, or all of these choices are correct. Typically, beacons are going to give you the health and status of the satellite. What causes spin fading of satellite signal? Circular polarized fading.
Hey, Chris.
Yes.
Your audio has just gotten really distorted.
Has it?
Sounds like maybe an internet issue. I don't know if you got something running in the background. It didn't do that at all last night.
Okay. Can you give me just a second here? I will go step away for just a second and see what's going on. And
it cleared up right there. It cleared up right there.
Okay.
If you want to go check something, you can. But yeah, it cleared up right there. It just
okay.
I didn't know.
Give me just a second. Somebody could be watching a movie or something like that.
Yeah.
Bandwidth.
Sure, no problem.
So give me like 30 seconds.
That's fine. All right. So I didn't want that to, I didn't know if that was going to last or what. I started hearing that and I'm like, okay, I'm going to give it like a second. And then, didn't want the audio to be bad. You guys need to hear what's going on there. So once again, thanks for joining us tonight. This is part 2. And I just now while he was doing that, I'm on the other monitor over here, and I put up part 3, which will start at 10 a.m. tomorrow morning, Texas time, which is, 1500 UTC. So 1500 UTC will be part 3 to this series. And then that will be the last part of it. The one we did in 2020 was 3 parts, and this one here is going to be 3 parts as well. So, but we just want to make sure that the audio and the feed is accurate for you guys, okay?
Okay, how was that? Is that any better?
Yeah, you sound fine now. It was just, It kind of started, and I was like, well, let me wait a second, and then you could hear it. It got worse and worse and worse, and as soon as I said something, it got better, so I guess I scared it or something.
So I use T-Mobile's 4G hotspot, or 5G hotspot, and it's usually solid. Like we can stream 3 or 4 different HD things, and occasionally maybe it has a blip, so.
Yeah, maybe so. All right, well, you're good now, man. I appreciate it, thanks.
Okay. All right. So let's see here. Where were we? What causes the spin fading of satellite signals? Circular polarized noise interference radiating from the sun, rotation of the satellites and its antennas, Doppler shift of the received signal, or interfering signals within the satellite uplink band. Answer to that one will be B, the rotation of the satellite as it spins and the antennas face towards you, and then they'll spin away from you. You'll get that spin fading. What is Doppler shift in reference to satellite communications? Change in satellite orbit, a mode where satellite receives signals on one band and transmits on another, an observed change in signal frequency caused by relative motion between the satellite and the Earth station, or a special digital communications mode for some satellites. It's going to be an observed change in the signal frequency as it's passing over you. There will actually, just like you'll hear the fire truck pass in front of you, and the pitch of the siren will drop. Same thing happens with your signal on your radio. So, which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? You check your signal strength report using the telemetry. Listen for distortion on your downlink signal. Your signal strength on the downlink should be about the same as the beacon, or all of these choices are correct. So your signal on the downlink should be about the same as the actual beacon itself. So you'll be able to tell that. What is the impact of using excessive effective radiated power on a satellite uplink? Possibility of commanding the satellite to improper mode, blocking access to others, overloading, the satellite batteries, or possibility of rebooting the satellite control computer. If you overload the receiver, basically you're going to be blocking access to not only others but also to you too. And so you may cause the satellite to kind of go quiet until it can recover in a couple of minutes. What is meant by the statement that satellite is operating in UV mode? The satellite uplink is in the 15-meter band, and the downlink is in the 10-meter band. Satellite uplink is in the 70 centimeter, and the downlink is in the 2-meter band. Satellite operates using ultraviolet frequencies and satellite frequencies that are usually variable. Proper answer is going to be you are speaking to the satellite on 70s and listening on 2-meter there. Okay. So these are the groupings here that we're going to be going over. So your computer goes ham digital. There's a lot you can do between your computer and the radio now. Really, really neat things. So we're going to start with the original digital, CW. Or Morse code, as we like to call it. That's we've always called it CW. Continuous wave is what that means. Like I said, we call that the original digital. On off is basically how a digital signal works. So looking at the band plan, usually between the 50.1, 144.1 on 70 centimeters, the first little 100 kilohertz there. On most of the bands, you will find a CW portion limited to only Morse code. In this case, this is showing you 50 megahertz and also 144 megahertz, and where the CW is on the band plan. You'll actually see that on a band plan that you can download online. So if you really want to use Morse code, and you just having a whole lot of problems, you just can't get it, you can use an electronic keyer. I am not going to say that's cheating, because CW can be difficult for some. So an electronic keyer is a device that will assist in manual sending of Morse code. We also receive audio, transmit audio, and the transmitter keying are signals used in computer radio interface for digital mode operation. So not only can you plug a CW key in, but you can also connect your radio. You can connect it to a TNC, a terminal node controller, which is kind of the analog to that would be like a dial-up modem. That's on the old school, kind of dating myself, on the old school dial-up internet. So you connect your computer into that, and then that connects to your radio, and you can do digital communications that way. That's a lot of fun. So communications using digital voice or data systems via the internet is performed with a transceiver and a digital mode hotspot. In this, we're starting to get into some of the newer digital modes. When I say newer, within the past 10 years, you can actually get a little hotspot like this, and it can connect to the internet, and it can connect to other hotspots. It can connect to repeaters. So this is a kind of a neat little thing that's coming around. And if you have been around amateur radio, and even if you're not licensed, you may have heard of hotspots or DMR or Fusion or D-Star. These are all digital technologies that kind of rely on the internet. And this little hotspot right here is one, it's just another part of that. So these are digital communications, packet radio. Um, IEEE 802.11, which is I always related that to Wi-Fi. JT65 is going to be another one. Um, so you just, like I said, you connect your computer to the line in using a transceiver speaker connector, or you can go into a device, a TNC, or a device that will allow you to connect to a radio at like an external sound card type thing where you have fine controls. All of these can connect your computer to your radio, and then you can do different digital modes, which is really, really neat. So you can pick out a signal from basic noise that you actually can't hear anything, but the radio will actually be able to hear and decode. So a digital mode capable of operating in low signal to noise conditions and that transmits on a 15-second interval is called FT8. This is a really neat, very long distance digital mode that, I mean, you can go thousands and thousands of miles with very low power, and the software is able to pull out your weak signal, is what it is, and decode that and actually show you on your screen what it's doing. So it's pretty cool technology. This is going to be more in the HF spectrum. So if this is something that you want to give a try, you might have to perform study and get your general at least to do this over HF. In a station configured to operate FT8, the transceiver audio input and output are connected to the audio input and output of the computer. The computer does have to be running some software. It's called WSJTX-X. This is the software that is for FT8 and the other modes that are similar to this. So FT8 is pretty neat. You might look into it, see if it's something that you're interested in. It can be a lot of fun, and you can really, really, pull out some very weak signals based on your location. So some of the operating specialties supported by digital mode software in WSJT include Earth, Moon, Earth. So if you want to try and bounce a signal off the moon, this is one application that will do that for you. It will send a FT8 signal out, and then it will wait for a response, or not a response, a reflection, and then give you you basically have bounced a signal off the moon. Weak signal propagation beacons. This is similar to a mode that we call Whisper. It's a very low power a beacon that it will transmit a low power signal, and the sole purpose is just to see how far you can get a response, not a response, but a yeah, you can be heard, and then that computer that hears you can report it and say, hey, Chris in Texas on 1 watt just got, Canada or anywhere really. I mean, South America on 1 watt. It's very, very low power. The following may be included in packet transmissions. So when a packet is sent out there, they will include a checksum. That way, the application can be like, okay, I have received all information, or please send the information again. It will have a header which contains the call sign of the station where the information is being sent, so it's not just a blind transmission with no destination. If it does receive an error, it'll have an automatic repeat request, and so it will retransmit, say, please send this information back. Okay. An ARQ transmission system is an error correction method in which receiving stations detect errors and send requests for retransmission. Basically, it's like you're talking to somebody and you miss something. You say that again, or can you repeat that? It's the same functionality there. With multipath propagation, error rates are likely to increase on data. Multipath means you're transmitting and your signal may be going multiple directions and then being heard by the receiver. So you may get some kind of an echo. And if that happens, you might get more error rates that require a response, a re-response there to in order to get the full message. So an application of APRS, App Automatic Packet Reporting System, um, something that is really neat. It provides real-time tactical digital communications in conjunction with a map showing the locations of stations. I've used APRS and I love it. It's one of my favorite things to do. It's just a simple beacon that transmits your location and your call sign and maybe a little message, but it's transmitted out there. And then you can actually map it using the internet. There's a website that I usually go to. It's called aprs.fi, Foxtrot India, and it will display APRS information from all over the world. Really neat stuff. Really a lot of fun, inexpensive, and if you want to give that a try, you can. The barrier into entry is pretty low. So, what kind of data is transmitted by APRS? If you look at this little graphic here, the GPS, it'll give your speed. Then your car will transmit that to a digipeater, and then or another radio, which is connected to the internet, and then that will relay to the APRS websites and servers, and then that can be looked at online. So you get your GPS position, you can send text messages, which is really neat. A lot of APRS stations will beacon data. It's beacon data. It's not what I meant to. Weather data, excuse me. It will beacon weather, and so you can get weather on your heads-up display depending on what your actual radio is hearing. So we have an abbreviation here. This is moving on from APRS. The abbreviation PSK means phase shift keying. And what this is some high-end transmitter they'll have a built-in digital interface for PSK and also what we call RTTY or RTTY. If your radio has this built in, you don't have to buy anything else, and you can operate digital modes like PSK31 or RTTY or RTTY, where it just typed messages. You can actually watch people type as they're transmitting. You can see the letters pop up as they're typing. Kind of a very old school technology, but it's still alive and well in amateur radio, and it's really neat to see it in action. So that's something to check out. Still going digital, a gateway is the name given to an amateur radio station that is used to connect other amateur stations on the internet. So the gateway is going to be the link from one station to the next. This can be any number of modes. This can be what we call IRLP. That's a kind of a generic connection. It can be Echolink. It can be All Star. It can be in the digital. Talking about digital, it can be proprietary IPsec from Motorola repeaters or anything that allows you to connect repeaters and transmit voice over IP, VoIP. So there's a lot of repeaters out there that are connected, and you can actually use your radio, connect to another on the fly, connect to another repeater, and have a conversation. The way you will do that, the primary way, is using what we call dual tone multiple frequency, DTMF, or touch tone. Just like on your phone, you have touch tones, and on old school phones, you have touch tones. Those are on mini radios also, and that is how uh, you use your radio. It's usually some key command, and then the node number that you want to connect to, and then the magic happens behind the scenes, um, and then you get over-the-air access to other repeaters on the fly that you have actually connected yourself. So if you look at these two radios, you can kind of see right underneath the towards the bottom of it, you can see the number pad right there. That's the DTMF tone keys. The shorter Yaesu one has it also. It's a little bit smaller. So that's how you would remotely control the repeater telling it who you want to connect to. So pretty cool things. That sort of replaced auto patching, which was using your phone to actually dial a phone number and call. Um, Back before cell phones, that was a very common thing in repeaters. Not so much anymore, but so VoIP is used in amateur radio. It's a method of delivering voice communications, just like I said, using it's kind of like Skype, sort of using VoIP. It's the same thing, but it's adapted for specifically for ham use. I did mention Echolink. That is a another protocol that enables amateur stations to transmit through repeaters without using the radio. So you don't have to have a radio in order to use some of these VoIP protocols. Echolink just happens to have the ability where you can connect to other users directly, or you can connect to any other nodes. Those nodes could be repeaters. It could be an HF radio. It could be, you name whatever kind of connection is out there, and it'll tell you. It's pretty neat, and it's free to use. In order to use Echolink to communicate using repeater, you must register your call sign and provide a proof of license. So as part of the registration, one of the things that you're going to do, create your username, your password, then you have to prove that you are a ham because it is a ham technology, because we don't want just anybody getting on there and getting on a VoIP, connecting VoIP to a repeater and them not being a ham. So this is a ham specific application, and you have to prove that you are um, in fact an amateur radio operator. An analog fast scan color TV signal is the type of transmission indicated by the term NTSC. NTSC is a standard of television here in the U.S. Think of fast scan color TV as you're setting up a video and you're actually transmitting the video, and it could be audio over the air. It usually takes a lot of bandwidth, but it's like watching TV, but that you can interact with. Um, so the typical bandwidth of an analog fast scan TV is on 440 is about 6 megahertz. There's a lot of information that gets sent through the fast scan TV stuff. And if you go up even higher bands, you may have even more, maybe 25 megahertz, depending on what it is that you're actually trying to send. So the spectrum of the video signal, this is kind of breaking down what it is. You've got your audio, you've got your video in there. A little bit of magic is performed. It's all combined together, and then that is sent out from the radio itself. So that is another activity we do. The way you identify with fast scan TV is you just put your call sign like in a lower third or something like that, to where anybody listening to this can just look and see, okay, there's their call sign. That's who it is. So you do have to identify with that way too. So going back a little bit, what is CW? It's a type of electromagnetic propagation. Is it a digital mode used primarily on 2-meter FM? Is it a technique for coil winding, or is it another name for Morse code transmission? It's going to be another name for Morse code transmission, excuse me. Which of the following UHF and VHF frequency ranges are limited to CW only? Where can you find CW only? In this specific one right here, 50 to 50.1 and 144 to 144.1 megahertz, or the 219 to 220, 420 to 420.1, 902 to 902.1. Actual answer that we are concerned about is 50.0 to 50.1, and then 144.0 to 144.1. Those are going to be where you will find CW on most VHF and UHF areas. What is an electronic keyer? Is it a device for switching antenna from transmit to receive? A device for voice-activated switching from receive to transmit? A device that assists in manual sending of Morse code, or an interlock to prevent unauthorized use of radio? It's going to be C. It just helps you in manual sending of Morse code. What signals are used in a computer radio interface for digital mode operation? Receive and transmit mode, status and location, antenna and RF power, receive audio, transmit audio, and transmitter keying, or NMEA, GPS, location, and DC power. It's going to be receive audio, transmit audio, and transmitter keying. The D doesn't even make sense. A is for something else, and then antenna, RF power, something else. So the answer is going to be C. It's about your audio. What function is performed with a transceiver and a digital mode hotspot? Communication using digital voice or data systems via the internet, FT8 using AFSK, RTTY encoding and decoding without a computer, or high-speed digital communications for media scatter. When it comes to digital modes on a hotspot, you are talking about digital voice or digital data actually being sent out over the internet from your radio itself. Which of the following is a digital communications mode? Is it going to be packet radio, IEEE 802.11, FT8, or all of the above? So all of these are a digital communication mode that is available in our amateur radio toolbox. Which of the following connection is made between a computer and a transceiver to use computer software when operating in digital modes? Computer line out to transceiver push to talk, computer line in to transceiver push to talk, computer line in to transceiver speaker connector, or D, all of these are correct. So the connection made is, the connection made, sorry about that, is you're going to connect to the computer line in to the transceiver speaker connector. This allows the audio card to actually interact with the the transceiver to interact with the computer, and the computer can hear it, is basically what it is. What is FT8? It is a wideband FM voice mode. It's a digital mode capable of low signal to noise operation, an 8-channel multiplex mode for FM repeaters, or a digital slow scan TV mode with forward error correction and automatic color compensation. So FT8 is what we call it is a low, a weak signal mode, very, very weak signal mode. It's capable of low signal to noise operation. You may not hear anything at all, but a radio can actually pull the information out of any static. So it's pretty neat. Give it a try. How are the transceiver audio input and output in a station connected in a station configured to operate using FT8? To a computer running a terminal program and connected to a terminal node control unit. You can connect it to the audio input or output of a computer using the WSJT-X software. You're going to connect it to an FT8 conversion unit, a keyboard, and a computer monitor, or to a computer connected to the FT8converter.com website. Proper answer is the audio input and output of a computer is where you're going to connect it, and the software is going to be the WSJT X software. Which of the following operating activities is supported by digital mode software in the WSJT suite? Earth, Moon, Earth, EME, weak signal propagation, meteor scatter, or all of these are above. All these above. In the actual suite itself, it's going to be everything. It's going to be all three of these that show up that you can do. Which of the following is included in packet radio transmissions? A checksum which permits error detection, a header in which contains the call sign of the station in which the information is being sent, automatic repeat request in case of error, or all of these choices are correct. Going to be all of these choices are correct. Each one of these is sent with every packet, every single packet that's sent will contain all this information.
It's doing that. It's doing that. That weird noise again.
Man, I don't know.
It seems to clear up. It seems to clear up on its own after a few minutes. It's kind of like it sounds like a robotic voice, and then you can hear an echo of yourself as well. It's like there's two of you in there. It's gone now.
Gosh, I don't know.
It's gone now. Yep. Just keep going, man. Okay. I don't want anyone to miss any of the questions and answers. So I think we got pretty much through that last one. So before you started this one, I wanted to call it out. But just go with it, man. Thanks.
Okay. Yeah, I had a little bit of an internet blip earlier. I had to restart my modem, so hopefully I'm not having issues out there. And of course, I normally don't ever have any kind of issue until I really, need it like today. So
exactly, yeah. No worries. Thanks, man.
Okay. So what is an ARQ transmission system? It's going to be a special transmission format limited to video signals, a system used to encrypt command signals to an amateur radio satellite. Error correction method in which the receiving station detects errors and sends requests for retransmission, or a method of compressing data using autonomous Q codes prior to final encoding. The actual answer will be C. It's an error correction method in which the station receives it and requests a retransmission. What effect does multipath propagation have on transmissions? Transmission rates must be increased by a factor equal to the number of separate paths observed. Transmission rates must decrease by a factor equal to the number of separation paths observed. No significant changes will occur if the signals are being transmitted using FM, or error rates are likely to increase. Usually it's a long answer, but this one, it is error rates are likely to increase if you experience a multipath propagation while you're trying to do digital. Which of the following is an application of APRS? Does it provide real-time tactical digital communications in conjunction with a map showing the locations of the number of packets transmitted via PACTOR using a specific time interval, providing voice over internet connection between repeaters, or providing information on the number of stations signed into a repeater? It's going to provide real-time tactical communications, location, text messages, maybe weather. Pretty neat stuff. Give it a try. What kind of data can be transmitted by APRS? GPS, text message, and weather data, or all of these above? It's going to actually be all of these above. I gave that just one question prior. What does the abbreviation PSK mean? Pulse shift keying, phase shift keying, packet short keying, or phase slide keying? So when it comes to digital communications, it's going to be phased shift keying is what it is. You'll find that in DMR and Fusion, and I think also in D-Star, which are some digital modes of amateur radio. What is an amateur radio station that connects other amateur radio stations to the internet? A gateway, a repeater, a digipeater, or a beacon? The station that connects them is going to be the gateway. That's usually what's connected to the internet itself. What is the Internet Radio Linking Project? A technique that can connect amateur radio stations such as repeaters via the internet using VoIP, a system for providing access to websites via amateur radio, a system for informing amateurs in real time of the frequency of active DX stations, or a technique for measuring signal strength of an amateur transmitter via the internet. Proper answer is it's a technique to connect amateur radio systems such as repeaters via the internet using VoIP. Okay. What type of signaling uses pairs of audio tones? Pairs of audio tones. DTMF, CTCSS, GPRS, or D-Star. So if you remember what the audio tones were, those were DTMF codes or tones that you transmit from your radio itself. How is over-the-air access to IRLP nodes accomplished? By obtaining a password sent via voice to the node, DTMF signals, entering the proper internet password, or using CTSS tone codes. It's there's going to be DTMF. That's the primary way in many of the systems of how you're going to connect to another station or another node. What is voice over the internet protocol, VoIP? Is it a set of rules specifying how to identify your station when linked over the internet to another station? Technique employed to spot DX stations, a technique to measure modulation quality of a transmitter using remote sites monitored via the internet, or a method of delivering voice communications over the internet using digital techniques? Proper answer is going to be a method of delivering voice communications over the internet using digital techniques. Which of the following protocols enables an amateur Echolink? Free software that you can download and download. You register, verify, and then you can access the network. What is required before using the Echolink system? Uh, Complete the required Echolink training, purchase a license, register your call sign, provide proof of license, or all of these are correct. Proper answer is going to be register your call sign and provide proof of license. So what type of transmission is indicated by the term NTSC? Is it going to be a normal transmission mode and static current, a special mode for Earth satellite uplink, an analog fast scan color TV signal, or a frame compression scheme for TV signals? NTSC has got that is completely involving TV, and it's a television standard, so it's going to be an analog fast scan color TV signal. What is a typical bandwidth of AM fast scan analog fast scan TV transmissions? AM fast scan analog, more than 10 megahertz, about 6 megahertz, 3 megahertz, or 1 megahertz. It's gonna be about 6 megahertz. That's pretty typical. I got a lot of information to pack in there, so a lot of bandwidth there. Okay, we're going to move on to section 3 here, or sub-element 3, excuse me, multimode radio excitement. So, a unit combining the functions of a transmitter, and a receiver. We call that a transceiver. So we just kind of mash those two words together. It transmits and receives. That is a transceiver, is what we call that. Single sideband is the voice mode model most often used for long distance weak signal contacts on VHF and UHF bands. Single sideband really it has an advantage over FM, can really travel long distances, even like I said, even more than FM is able to. Primary advantage of the single sideband over FM for voice communication is single sidebands have a narrower bandwidth. much narrower bandwidth. And then a disadvantage of FM compared to single sideband is only one signal can be received at a time. Period. Um, Single sideband is also a form of amplitude modulation. It's a form of AM, the old, like, in your car, you have AM. So if you look at this little graphic here, you will see an AM signal on the up in the top right there. So what is on, you have your center frequency in the very center right there, upper sideband, lower sideband. What is on one is on the other. A single sideband, half, there's no real reason to use that much bandwidth for communication, so we'll take away the lower sideband and keep upper. So that is going to be single sideband is what that is. Trying to help understand what that means. So looking at the three spectrums here, carrier only CW, and then the middle one we've got tones produced both sides of the bands. So you have your center frequency right there, as well as both upper and lower sidebands. And the sidebands are kind of you have your middle. Well, somewhere there has to be that information, and that goes upper sideband or lower sideband, higher, a little bit higher frequency and a little bit lower. So that's where that kind of comes through. If you remove the sideband and suppress the carrier, then you have single sideband. You get a much narrower signal, and is able to really radiate a lot farther. That's where you will get most of your distant contacts, is on sideband. So the upper sideband is normally used for 10 meters HF, VHF, and UHF single sidebands. Sideband communications as our upper sideband is normally used for 10-meter HF, VHF, and UHF single sideband communications as our communications mode. Excuse me there. Kind of got my tongue twisted. The function of the single sideband CW-FM switch on a VHF power amplifier is to set the amplifier for proper operation in the selected mode. Each one of these modes requires configuration, especially CW, because it's transmitting, stop, transmit, stop very quickly, and it needs to be put into CW mode in order to prevent it from just from the TR switch, breaking or whatever, because it's not properly set. Modulation describes the combining speech with an RF signal carrier. So the modulation is going like in an FM signal. You have your signal, but then you got to have some sort of an RF carrier to carry that signal. So that's what you actually will see on FM. On your dial, you will see 14652. That is your modulated carrier is there, and then your FM actually has a little bit wider bandwidth that it's transmitting. Single sideband. Why is it used? Because it's 3 kilohertz is the approximate bandwidth. 3 kilohertz is very little compared to like AM, which is twice that. FM is much more. So it's a very narrow amount of information, or very narrow signal. So you don't take up a whole lot of unneeded bandwidth for your communications. So if you yesterday we talked a little bit about being on the band edge, or the your limits, like where you can actually operate. So if you look at this, this is going to give an example of 21450. So if you put your say you're a general class, or and you're wanting to go right on that edge of where advanced and extra class can be, but you're a general, so it's fine. When it comes to sideband, you have to determine, am I on lower sideband or am I on upper sideband? Depending on the band is kind of standard. So in this case, upper sideband is where we are going to be. So 21275 if you put your VFO right on that, you're on upper sideband, so you don't have to worry about bleeding over down into the extra because you're operating 3 kilohertz upper sideband. So you have your signal, and then you've got a little bit. You're using the bandwidth above the carrier. As well as if you look at the other one, 21450, if you place your VFO right on that, you will be 3 kilohertz out of band. You'll be 3 kilohertz out of what you're even permitted to be on the band. So you really want to kind of avoid the band edges or your permission, like where you can actually operate. You want to stay away from those at least a little bit so you don't accidentally do something you're not supposed to. The RIT or clarifier could be used if the voice pitch of a single sideband signal is a signal returning to your CQ calls, if it seems too high or low. A RIT is kind of like a fine tune button in a way. It's usually on a radio. It could be a knob, or it could be a menu item somewhere in there. And basically what it is, like I said, it's a fine tune. It's for your big knob will make large changes. The RIT will just kind of do fine, and it will help make that Mickey Mouse sounding person bring their voice back down to a normal range. So the name of the circuit that generates a signal of a desired frequency is called the oscillator. That is the generator of the sine wave. That's what it's called. It's called an oscillator. And if you look in those two pictures right there, that will show you. One of them is an actual component, and the other is the kit that will give you the oscillation that you need. The type of emission that has the narrowest bandwidth is CW. That's 150 hertz. That's why in amateur radio we say when all else fails, CW can get through, because it is such a narrow bandwidth that that helps really get your signal out there. 150 hertz is the approximate bandwidth required to transmit a CQ signal. If you look at the signs there, you can really kind of visualize that very narrow bandwidth, and you can really pack a lot of users into one little area. A 24 hertz receiver filter bandwidth provides the best signal to noise ratio for single sideband. That's a filter there that, depending on what kind of filter it is, a bandpass filter, it will help narrow down and isolate you from others. The advantage of having a multiple receive bandwidth choices on a multimode radio is it permits noise or interference reduction by selecting a bandwidth matching the mode. So every mode has its bandwidth, and that will help you really match what you're trying to do. Sensitivity is a term that describes the ability of a receiver to detect the presence of a signal. So if you look at this, what this is this is basically helping you hear only what you want to hear. If you have just a default, your radio is going to listen to everything out there. If you have a high or a low pass filter, depending on which one, that will kind of isolate, either higher or lower. Help you pull out if the background from out of the background noise. Or you could have your beat your what is this, the shift from the center of kilohertz right there. Each one of these is basically showing a filter in use in order to kind of help you pull out that signal there. A mixer is used to convert radio signals from one frequency to another. So a mixer is going to be when you talk into the microphone, it's your voice is going to go into the mixer. It's going to take the oscillator. It's going to take your voice. It's going to take a couple other things, combine it all together, and send that out to the antenna. That is what the mixer does. And this is a block diagram of that. You'll want to just really kind of study that. Make sure you understand what kind of what it does. You don't have to memorize every single piece uh, together, but if it says, what is a certain part, you'll want to know, hey, that's a local oscillator, or the signal coming in, or whatever it is that it's asking, and it won't break it down and make it difficult on you, but you do need to kind of familiarize yourself with this because this is a common component. The term that describes the ability of a receiver to discriminate between multiple signals is called selectivity. So selectivity is like, say you're in a room full of people and you're trying to everybody's talking, but you're trying to talk to one single person. Your ear is listening, you're focused on one person. Your ear is listening to that one person. You're being selective of what you are hearing. So that is what the selectivity in a radio is. Your radio is listening to every single thing at the same time. But in order to hear what you want, you're tuning that knob tuning the VFO knob to a specific point on the dial, and you're causing your radio to be very selective for just this one little area that you want to listen to. Think of it as like your ear listening to, you're in a large group of people, you're trying to hear one person, and so you're really focusing and listening to one, but you still have all that noise and everything in the background. This is showing you uh, using another filter, and this is showing you how or what the isolation of that noise combining with um, being discriminated out there. An RF amplifier. It's a commonly referred to as the front end of a radio. So these are going to be the simplified block. This is a block diagram of a basic front end of a radio here. So everything comes in. It's going to go through the RF amplifier, the mixer, the filter to filter things out. The amplifier demodulator takes out the oscillator, the oscillation, and then the audio amplifier itself. So what it does is the RF preamp is installed between the antenna and the receiver itself. So let's see here. You got the antenna, and then this kit is actually this is going to be a receiver right here. Excuse me. A transverter will convert the RF input and output of a transceiver to another band. So that is something that it's just going to convert from one band to the next. A technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel is basically how DMR works. You have two what we call time slots. Each one of these time slots is 12.5 kilohertz, and the the radio will actually transmit a digital packet, stop transmitting, and then in another time frame it will transmit another digital packet for something else. And so it's the constant on-off switching of the transmitter, and that basically gives you the ability to have multiple two repeaters built into one because of the time switching. DMR is a lot of fun. If you want to know more, feel free to ask. Um, there's a lot of information that makes DMR. It's pretty cool, pretty neat digital mode. Um, so if you're interested, feel free to ask. That's like I said, that's pretty no. I know Jason's covered a lot of DMR radios, but we're not going to get into depth of how it actually works. So a color code is used on DMR to um, give access to a repeater or another radio. A color code on a DMR radio is no different, except it's digital, is no different than a um, like a CTSS or a DCS code. No different. It does exactly the same function. It is what prevents interference, and it actually will cause the repeater and it's to activate. And it can be anywhere from one to color code 1 to 15. It's just a number is all it is. If you want to join a repeaters talk group, you have to program your radio with the group's ID or code. So let's just give an example like North America. North America is talk group number 93. You have to program that into your radio. One side effect of DMR is it can be a little overwhelming. At first, there is a learning curve for learning how to program it because it is a digital standard. It's not meant for it wasn't originally meant for amateurs, but we, as with everything, we take it and make it our own. So DMR is a lot of fun. Like I said, color code is like a CTCSS or DCS code, um, and it is required on a DMR repeater. You have to have a color code. You cannot. It's not optional. A talk group on a DMR digital repeater is a way for groups of users to share a channel at different times without being heard by other users. So it's like think of it as a chat room. So you have North America. If somebody's in North America and somebody else is on another talk group, let's say like worldwide, that person who's on North America will not hear whoever is on worldwide because they are in different chat rooms, essentially different talk groups. Um, and so that's one of the neat things about DMR. A DMR code plug, or which is it's a code plug is like a programming file. It contains all the information for all the repeaters, the talk groups, like channel information, contacts, radio, like what your buttons do, anything that your radio needs to function on DMR. That's what that is what it's for. It's got all that information, and you upload that into your radio, and the radio says, "Okay, I know what to do now," because the radio from stock will just be blank. There's literally the radio doesn't know anything at all. So you have to program everything that you want, and that's where it can kind of get a little overwhelming at times because you have to put all that information in there. So another technology is what we call D-Star. This one is it's kind of an older. This one is a ham radio specific technology put out by ICOM. Your call sign must be programmed into the D-Star radio, digital smart technology for amateur radio. It's a digital transmission or digital radio also. Um, it has some really neat functions, like it can track down if you're trying to find somebody, you can put their call sign in there and it will locate them in the system and connect you with them, which is that's a pretty neat technology. Amateur radio based data network using commercial Wi-Fi equipment with modified firmware best describes an amateur radio mesh network. These are really neat. Here locally, we actually have a mesh network running, um, providing backup communications for or backup internet, and then also it's powering a internet connected DMR radio or repeater in the city. It is literally Wi-Fi citywide miles. So we've got one node is 5 or 6 miles away from another, but they're linked together, so it's really neat, and it just uses off the shelf hardware and custom firmware to make that happen. Some questions. What is a transceiver? Basically,
It's
I
it's
trans.
doing it again. It seems to do it all the time when you get to the questions. I don't know why that is. So
Okay, okay, pass. Go ahead, pass. Yeah.
skip the
Um.
questions.
Um. Yeah. How about now? What are you doing? Any better?
No, I usually last like a minute or so, something like that. So
Let me let me try something here.
it's getting a little bit better.
Let me stop my video and
Okay.
see if that's any better. Is that any better?
I can still
One,
kind of hear
two,
it.
three, four.
Okay, it's gone now. But I mean,
Okay.
again, it was gone the last 2 or 3 times. It was gone after a minute or so, anyway. So okay,
Mm.
all right, go ahead. Sorry.
Well, just keep just let me know that way.
Sure.
Like you are that way. I don't just keep trucking on and nobody can understand anything.
Right. Exactly.
Um. Okay. So what is a transceiver? It's going to be a device that combines a receiver and a transmitter. I didn't read through all those. Just because I got a little distracted there. But a transceiver is a receiver and a transmitter combined together in a single box. So it's a transceiver. Okay. Which type of voice mode is often used for long distance, weak signal contacts on the VHF and VHF bands? FM, DRM, SSB, or single sideband, or PM? Which one of those sounds right? It's going to be single sideband. And our correct answers have now changed to green. What is a characteristic of single sideband compared to FM? Single sideband signals are easier to tune incorrectly, less susceptible to interference, have a narrower bandwidth, or all of these are correct. Single sideband is going to be going to have much narrower bandwidth than other modes. Which of the following is a disadvantage of FM compared with single sideband? Voice quality is poor. Only the signal can be one signal can be received at a time. FM signals are harder to tune, or all of these are correct. It's going to be only one signal can be received at a time. Um, so that is a disadvantage there. Which of the following is a form of amplitude modulation? Spread spectrum, packet radio, single sideband, or phase shift key? Answer is going to be single sideband. That is a form, it's a stripped down form of AM radio. Which of the following is normally used for 10 meter, HF, VHF, and UHF single sideband communications? In these three bands, we use upper sideband. If you look at a band plan chart, it will tell you what to use. So I believe, if I remember right, 20 meters and up, it uses upper sideband, and then 40 and below use lower sideband. That's just the decision that was made. I don't know what the reasoning is, but it works pretty well. What is the function of the single sideband CW FM switch on a VHF power amplifier? Changes the mode of the transmitted signal, sets the amplifier for proper operation in the selected mode, change the frequency range of the amplifier to operate the proper segment of the band, or reduce the received signal noise. It's going to be, it prepares the amplifier, sets the amplifier for proper operation in the selected mode. Each mode is unique in how it works, and an amplifier will need to be set. So, which of the following describes combining speech with an RF carrier signal? Impedance matching, oscillation, modulation, or low pass filtering? So you're going to take your you talk into a microphone that has to be combined with an RF carrier, and we call that modulation. Don't configure that with or confuse that with oscillation. Oscillation is part of the what is part of the RF carrier signal. Modulation is the combining of those. What is the approximate bandwidth of a typical single sideband voice signal? 1, 3, 6, or 15? We talked about this one specifically. It's very narrow. It's 3 kilohertz. Which of the following controls can be used if the voice pitch of a single sideband signal seems too high or or a low. It's going to be the AGC or limiter, the bandwidth selection, the tone squelch, or the receiver's RIT or clarifier. To fine tune that, remember, it's going to use the RIT or the RIT, the clarifier knob or menu. What is the name of a circuit that generates a signal at a specific frequency? Reactance modulator, product detector, low pass filter, or an oscillator. This one is going to be the oscillator. It generates a signal at a specific frequency. Which of the following types of signal has the narrowest bandwidth? We talked about this one. Is it FM, sideband, CW, or slow scan TV? This one's going to be CW. It's got 150 hertz bandwidth there. What is the approximate bandwidth required to transmit a CW signal? I just gave that answer away. 2.4, 150, 1,000, or 15 kilohertz. It's going to be 150 hertz. That's going to be about the most narrow out there. Which of the following receiver filter bandwidths provides the best signal to noise ratio for single sideband reception? 500 hertz, 1,000 hertz, 2,400 hertz, or 5,000 hertz. The receiver filter bandwidth is going to, that gives you the best, is going to be 2,400 kilohertz. That's one of those ones you just kind of have to memorize. There's not really an easy way to remember it other than just old school memorizing. What is the advantage of having a multiple receive bandwidth choice on a multi-mode receiver? What is the advantage of having multiple receive bandwidth choices on a multi-mode receiver? It permits monitoring several modes at once by selecting a separate filter for each mode, permits noise or interference reduction by selecting a bandwidth matching the mode, increases the number of frequencies that can be stored, or increases the amount of offset between receive and transmit. This one is going to permit the noise interference reduction by selecting the bandwidth, depending on what it is. You don't need to listen to 25 kilohertz large amount of bandwidth for just a little single sideband. There's no reason to do it. So setting it into sideband mode will your radio, you'll actually see your radio kind of narrow that down. Which term describes the ability of a receiver to detect the presence of a signal? Linearity, sensitivity, selectivity, or dual harmonic distortion. Which of the terms, or it's going to be which of the term is it going to be? This one is going to be sensitivity. This is going to be the ability to detect the signal, not the selectivity, which is listening in a specific. This is actually how sensitive is your radio. Which of the following is used to convert a signal from one frequency to another? A phase splitter, a mixer, an inverter, or an amplifier? This one's going to be a mixer. Okay. Which term describes the ability which term describes the ability of the receiver to discriminate between multiple signals? Discrimination ratio, sensitivity, selectivity, or harmonic distortion. This one is going to be selectivity. This one just kind of discriminates out all the extra nonsense that you don't want to hear. Where is an RF amplifier installed? Where can you put that? Between the antenna and the receiver, at the output of the transmitter power amplifier, between the transmitter and the antenna tuner, or at the output of the receiver audio amplifier. RF amplifier or preamplifier, excuse me, I was saying that wrong, is going to go between the antenna and the receiver. What device converts the RF input and output of a transceiver to another band? High pass filter, low pass filter, transverter, or phase converter. This one is going to take an RF input and output and transmit it on transmit it on another band. This is going to be a transverter. Many strange names, but that is something that we use. Which of the following describes DMR? Is it a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel? Automatic position tracking mode for FM mobiles communicating through repeaters? Automatic computer logging technique for hands-off logging when communicating while operating a vehicle? Or a digital technique for transmitting on two repeater inputs simultaneously for error correction? The proper answer is going to be a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel. Two time slots, basically, is what you can think when you read time multiplexing, two time slots. What is the purpose of a color code used on a DMR repeater? Um, it must match the repeater color code for access. It defines the frequency pair, identifies the codec used, or defines the minimum signal level required for access. This one is going to be, it must match the repeater code for access. Color code is your kind of like your key to actually access the repeater itself. How can you join a repeaters talk group? Register your radio at the local FCC office. Join a repeater owners club. Program your radio with the group's ID or code, or sign your call after the courtesy tone. You will program your radio with the talk group's ID or code. There's a lot of websites out there where you can find that information. Shameless plug, I run the DMR Texas webpage, so this is kind of right at my wheelhouse, but and happy to help with anybody who might be interested in DMR. What is a talk group on a DMR repeater? A group of operators sharing common interest, a way for groups of users to share a channel at different times without hearing the other users on the channel. A protocol that increases the signal to noise ratio when multiple repeaters are linked together, or a net that meets at a specified time. It's a way for groups of users to share a channel at a different time without hearing each other. It may two people may be transmitting at the exact same time, but one will never hear the other one if it's set up properly and being used. What does a DMR code plug contain? Your call sign and CW for automatic identification, access information for repeaters and talk groups, the codec for digitizing audio, or the DMR software version. Code plug's gonna have all the information you need to access a repeater and the repeater's talk groups. How is a specific group of stations selected on a digital voice transceiver? Retrieving the frequencies from the transceiver's memory, enabling the group CTCSS tone by entering the group's identification code, or activating automatic identification. The answer is going to be on digital voice transceiver. It's going to be entering the group's identification code. That could be like a digital chat room, essentially. Which of the following must be programmed into into a D-Star transceiver before transmitting? Before you can do anything, what is it going to make you do? Is it going to enter? You're going to enter in your call sign, set your output power, choose the codec that you want to use, or all of these are correct. The one that is required is you're going to put in your call sign. You'll select your output power later. You don't get to choose your codec. It's built into the radio, so your call sign is what's going to be required. As soon as you turn it on, it's going to say, for the first time, it's going to want you to put your call sign in. Which of the following best describes an amateur radio mesh network? An amateur radio-based data network using commercial Wi-Fi equipment with modified firmware, a wide bandwidth digital voice mode employing DMR protocols, a satellite communication network using modified commercial satellite TV hardware, or an internet linking protocol used to network repeaters. Answer is going to be using commercial Wi-Fi equipment with modified firmware. A lot of times that's Ubiquiti hardware and modified firmware you can get it from different websites out there. Very neat. We're going to start a little bit of some interference protection, some filters. We'll do this and then take a short break after this little section here because we're going to start getting into a little bit more technical. Don't worry, we're going to cover everything that you need to know. So once we get through this, and we'll take a little bit of break. Let me get uh, a drink real quick, stand up, and then we'll push on through it. So we're going to talk about some filters here. These are going to be high pass, low pass filters, notch filters, whatever you may encounter. So some possible problems. If you receive a report that your audio signal is coming through the repeater is distorted or unintelligible, what could it be? You may be slightly off frequency. There's that chance. Your batteries may be running low. You may just be in a location. You may be down in a valley. These are just three things that you might check. If a transmitter is operating with excessive microphone gain, on sideband transmission on single sideband transmissions too high, it will result in distorted transmission. So if you one of the things you can turn up is it's kind of like a microphone volume. So you talk into it, you turn it up. If you turn it up too high, it can cause distortion because it's too much audio going through the radio and through the signal, and it will cause distortion. Um, you can talk farther away from the microphone. If you're told that your handheld or mobile transceiver is over deviating, just pull the microphone away. No need to yell. Microphones back, 20 years, 50 years were not very sensitive, and you had to talk loud and you had to talk, loud and in charge. But now microphones are very sensitive, and if you speak too loud into them, you'll get what over deviation or clipping, and it will just it won't sound very well. So just pull that microphone away um, from your mouth. The scanning function of an FM transceiver tunes through a range of frequencies to look for activity. That's a common thing to do if you want to um, program in a bunch of radios. You can hit the scan button and it will scan through all the memories, or it will scan through the VFO starting at whatever the band is and then just go through every frequency in that band and then start back over and start back over. And you'll be able to hear whatever your radio is near you. One thing you want to do is make sure all TV feed line coax connectors are installed properly as the first step to resolve non-fiber optic cable TV interference caused by your amateur radio station. One of the things that the connectors do is they help make sure that the signals are isolated from it, and if they're loose, you may be injecting some RF energy down into those. So just make sure that the TV connectors are properly connected. That way, you're not bothering your family or whomever just because of something simple like that. Some causes of interference: fundamental just overload. You may just be transmitting so much power that even though a TV or a radio may not be on the same frequency, it's just being overwhelmed because of you're transmitting out a TV receiver is listening to everything, and so it will hear you, and it can overload. Harmonics, which is a doubling, or not it's a double of the frequency. So 146, let's just say 146 at what is that, 292 megahertz, you will hear a harmonic. You will hear your voice. And it's just because it's a multiple of whatever frequency you're on. It's just a byproduct of RF. Spurious emissions. Your radio is just what we call noisy and just spitting out garbage that could be causing interference on something. Spurious emissions are what those are called. It's just over noisy radio from the electronics and things like that. Reports of garbled, distorted, or unintelligible transmissions are symptoms of RF feedback in a transmitter or receiver. So check your your coax, check your antenna, make sure you don't have some sort of a short out there that could be causing RF energy to come back into your radio. Um, One of the reasons you might want to use a shielded wire is to prevent coupling of unwanted signals to and from the wire. Coax cable typically is a shielded wire. It's typically got a center core, but then it's got a foam dielectric and then some sort of a copper or aluminum shield on it that helps contain all that RF energy into the coax itself, so you're not just spinning it all over the neighborhood. If a neighbor does tell you that that your station's transmissions are interfering with their radio or TV reception, make sure that your station is functioning properly and does not cause interference to your own radio television when it's tuned or to the same channel. One of the things if you set up a big station, your neighbors will see it, and all of a sudden now, anytime their TV doesn't work, it's your problem. That's just the nature of you know, human nature. That's got to be the problem because it's a big radio. So just make sure everything is functioning. Are you receiving any kind of problem or any kind of interference in your TV? If not, uh, there's a chance it's not you. So if a broadcast AM or FM radio receives an amateur radio station amateur radio transmission unintentionally, the receiver is unable to reject strong signals from outside the AM/FM band. It's just too much for the receiver. It can't. It's not able to receive. That's basically where you're overwhelming the receiver, and it doesn't know what to do. It's just too much power that it's receiving. To reduce or eliminate interference by an amateur transmitter to a nearby telephone, just put an RF filter, a ferrite choke on the telephone. I know back in the early days of DSL, this was common. I had one of these in every single phone port in the house, just because I didn't want to have any kind of RF energy going through my phone. If you overload a non-amateur radio or TV, you can get a little filter like this right here that will block out your amateur station from there, so that the TV it won't hear it. This is it's just a little filter, and we've got different kinds of filters depending on what it is, what's going on. A band reject filter can reduce overload to a VHF transceiver from a nearby TV broadcast. So some of the different kinds of filters here: low pass, high pass, band stop. Each one of these, if you look at it, a low pass will allow lower frequencies to pass and cuts off high. A high pass is exactly the opposite. It will allow higher frequencies, and at a certain frequency, whatever that it'll tell you on the filter what it is, that will be your cutoff. A band pass allows a certain band of frequencies, whether that's amateur radio. Let's just say that it's 20 meters. A band pass will allow 20 meters, and it will cut off everything else. You won't hear anything else on the radio outside of that. So, and then a band stop. Band stop is basically allowing everything except what you're actually tuned in on. If you've got somebody who's causing you a lot of QRM, you can use that band stop. We also call that band stop a notch filter. So if you're doing if you're shopping around for an HF radio, you'll hear that called a notch frequency or a notch filter, excuse me. And so these are the different kinds of filters that exist to help with interference. If something in a neighbor's home is causing harmful interference to your amateur station, let's make sure that we're being nice. Work with them to figure out what's going on. If they're just blaming you, and you can be like, I'm sorry, I wasn't even operating. My radios were not on at that time. But I want to help you try and find out. Politely inform your neighbor that the rules the rules that prohibit the use of devices which cause interference. Can't hurt to check and make sure that your station meets the standards of good practice. Let's be friends. Again, we're trying to enhance goodwill. One thing that you may try are some of these ferrite beads. These are what are they? I think they're little iron core things. They just snap onto cables. It could be television. It could be power. And what it does, it helps remove interference from electrical or usually electrical systems there. So if you get that report, just kind of be friendly, because you don't want to get into a fight about your radio, because they have no skin in the game, and it's your hobby. Okay, so we're going to start some more questions, and let me once we get through these, we'll just take a short break, drink a bottle of water, and stretch my legs, and then we'll pick back up. So, what might be a problem if you receive a report that your audio signal through the repeater is distorted or unintelligible? Your transmitter is slightly off. Your transmitter may be slightly off frequency. Your batteries could be running low, or you're in a bad location. All of these are going to be correct. These are some things to just kind of start the starting spots. What is a side effect of excessive microphone gain on single sideband transmissions? The side effect is that frequency instability, distorted transmission audio, increased SWR, or all of the above. Excessive microphone gain. If you're talking too loud into the radio on sideband, you will get distorted audio. So just talk normally. Talk, at a comfortable volume, because the microphones are very sensitive, and overdoing it will cause distortion. So what can you do if you're told your FM handheld or mobile transceiver is over deviating? Talk louder in the microphone, let the transceiver cool off, change to a higher power level, or talk farther away from the microphone. Answer is going to be D. The answer is never going to be talk louder into the microphone, because unless somebody says your audio is just very low, usually you're too close. You're rarely too far. What could cause your FM transmission audio to be distorted on voice peaks? Your repeater offset is inverted. You need to talk louder. You are talking too loudly, or your transmit power is too high. If you are distorted, another thing on voice peaks, you're probably talking too loud. Clipping is what we call that. What does the scanning function of an FM transceiver do? Checks the incoming signal deviation, prevents interference to nearby repeaters, tunes through a range of frequencies to check for activity, or checks for message left on a digital bulletin board. A scanning function is going to tune through a range of frequencies and just listening for activities. What should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission? Add a low-pass filter, a high-pass filter, a preamp, or be sure all TV feed line coax connectors are installed properly.
It definitely does not like the question section.
Is it still doing it? We've got
just started.
Okay, we've got about 3 or 4 questions here.
Just count to 20 or something.
Okay.
And
when did he write? No. Yeah, let me just.
It's getting better.
It
kind of dips down and then it comes back. I don't know. It's very strange.
What I may do is once we get through these, I may just disconnect and then reconnect, kind of a turn off and back on again, if that's okay.
Sure, yeah. Okay, it's gone now.
But okay. Yeah. Okay, so I got about 10 minutes.
Very strange. Okay.
Okay, which of the following may be a cause of radio frequency interference? It's going to be fundamental overload, harmonics, spurious emissions, or all of the choices are correct. And this In this case, it's actually going to be all three of them, A, B, and C. So the answer is D. Let me make sure I say that all of these choices are correct. What is a symptom of RF feedback in a transmitter or transceiver? Excessive SWR at the antenna connection, the transmitter will not stay on the desired frequency. Reports of garbled, distorted, or unintelligible voice transmissions, or frequently blowing of power supply fuses. RF feedback in a transmitter or transceiver will give reports of garbled, distorted, or unintelligible transmissions. Think of if you, a lot of times or back in the day, you may have heard RF in speakers. That was something that, if you had an unshielded speaker, you could hear radio, strong radio signals in a speaker sometimes. Um, which of the following is a reason to use shielded wire? It decreases the resistance of a DC power connection to increase the current carrying capability of the wire, to prevent coupling of unwanted signals to or from the wire, or to couple the wire to other signals. Think of this as coax, a common cable that we use. It prevents coupling of unwanted signals to or from the wire itself. So, which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? Make sure that your station is functioning properly and that it does not cause interference to your own radio or television when it's tuned to the same frequency. Immediately turn off your transmitter and contact the nearest FCC's office for assistance. Install a harmonic doubler on the output of your transmitter and tune it until the interference is eliminated, or all of these choices are correct. The answer is going to be A. Make sure everything is properly functioning. Your connections are good. Nothing is out of the ordinary. Don't contact the FCC. They're going to tell you to go away. They don't have time to talk to you. So I love these. Some of these answers are just great, but make sure you get the right one. Make sure your station is functioning properly. What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? The receiver is unable to reject strong signals outside the AM or FM band. The microphone gain of the transmitter is turned up too high. The audio amplifier of the transmitter is overloaded, or the deviation of an FM transmitter is set too low. Answer is going to be A receiver it's just unable to reject the strong signals outside the AM/FM band. The radio signals around it are just too strong and it can't handle it. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? Bandpass filter, low pass filter, preamp, or a ferrite choke? And this one it's a pretty easy fix or easy solution. Put a ferrite choke on there. That will help strip out that RF that may be coming back to you in your microphone cable. How can a fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? Block the amateur signal with a filter at the antenna input for the effective receiver. Block the interference signal with a filter on the amateur transmitter. Switch the transmitter from FM to SSB, or switch the transmitter to a narrow band mode. So you're going to put in a filter at the antenna input of the effective receiver right there where it comes into the TV. Just put a bandpass filter or a bandpass filter to block out the amateur radio bands. Hopefully that'll fix it. And if they're still on analog, that's sometimes you have to go out of the way. But digital, you don't run into a whole lot of issues with digital TV anymore. So, but you still need to be aware. Which of the following can overload a VHF transceiver by nearby commercial FM broadcast station? Installing an RF amplifier, using double shielded coax cable, installing bypass capacitors on the microphone cable, or installing a band reject filter. Can reduce overload from commercial by putting a band reject filter, because we don't operate on commercial FM. If you're blocking that out, you're not losing anything. So what should you do if a neighbor's home is causing harmful interference to your amateur station? Work with your neighbor to identify the offending device. Politely inform your neighbor about the rules that prohibit the use of devices which cause interference. Make sure your station meets the standards of good amateur practice, or all of these correct. It's going to be D, all of these correct. I will say the politely inform your neighbor about the rules, that may come off as aggressive. You may not want to do that till later on down the road. So those are the questions for this section. We can take just a short leg stretch break, and then we'll start getting into the electronic stuff, which is I don't want anybody to worry. It's a lot of information, but we're going to cover it, and we're going to make sure that you understand it. So we can just take a short break here, and I'll reset my connection also, and hopefully get rid of all the electronic whatever noises.
Okay, that'll work. Okay, so let's see. There we go, right there. Okay. All right, so yeah, everyone get up, take a break, grab a drink of water, bio break, whatever. And we'll circle back with Chris here in a minute. Appreciate the super chat I got a minute ago from Logan NC40M. Appreciate the support out there. You can donate super chats if you want to in the text below. You don't have to. This is a free class, but those are appreciated. So thank you, Logan, for being out there. And wanted to bring a couple of quick. I mentioned these yesterday, and also they are in the description of the video below. So those of you watching on the replay for the next 3 or 4 years, check the links in the description below. Sign up for my email list, hamradio2.com/email-sign-up. And I send an email about roughly about twice a week, sometimes 3 times a week. I usually send an email out before I go live. I did not send one today because I sent one yesterday about the 3-part series that was last night, tonight, and tomorrow. I'll send another one on Sunday. Got a live stream planned on Sunday night. We live stream every Sunday night at 7 p.m. Most every Sunday night at 7 p.m. And many times on Wednesdays at noon Texas time, which is about 5 p.m. UTC, 1700 UTC. So we keep up with all that and do live streams and welcome everyone to join us. So a lot of that and more other stuff, sales and whatnot, are shared on the email list. So do sign up there if you want to. One of the first places I tell people to go, people who are getting their new ham radio license, or if you've come from the GMRS world or not, BetterSafeRadio.com has pre-programmed radios in the GMRS world and in the ham radio world. You can save a 7% discount on all the radios on this website with the coupon code of HR2all7. And this one right here is this is their flagship. They've got a couple that are a little bit cheaper than this, but this is their flagship HT radio, handheld transceiver, dual band, 2 meters and 70 centimeters, the KG UV9 PX Papa X-ray. It has a channel capacity of about 999 memory channels, and about 920 or 930 of those come pre-programmed for you. A lot of simplex channels for ham radio, repeater channels for ham radio, GMRS channels for monitoring, commercial, police, fire, ambulance channels for monitoring, receive only. A lot of stuff that is dependent on your region about what gets used where. So you'll be able to scan through the channels and see which frequencies get used in your area and go from there. But it's a good entry-level radio because it already contains a lot of the information that you would have to put into a radio if you just bought one brand new off of Amazon or from a retailer or something like that. You have to program the whole thing yourself. So this is a really good good starter radio for someone who doesn't know what they're doing as far as programming goes. Chris has talked a lot about DMR tonight. And my go-to spot for DMR is Bridgecom Systems. Bridgecom is they carry what I consider to be the best dual band, handheld, and tri-band mobile radio right now, made for amateur radio in the DMR world. And this is by a company called Anytone. Bridgecom is one of the premier dealers of Anytone inside the USA. Bridgecom is in Kansas, or Kansas City, I think. I think they're on the Kansas side of Kansas City, but they're around Kansas City. And if you buy anything for Bridgecom, they give you a whole course of 150 videos about private videos about how to program these radios, how to do updates, how to do all the different features with them. And if you ever have any trouble, you can call them on the phone or you can email them directly. It's inside the United States, so the time zone's not weird, and they are really good customer support, customer service. So all the hot spots that Chris talked about earlier, DMR radios. Of course, there's a lot of other DMR radios that are out there as well. This one's pretty much the flagship DMR radio in the ham radio world right now. So as time goes on, that might change, but these are all going to be good. They've had 3 or 4 models of this HT, and the latest one is really good. They got pictures of the hotspot there. That's the mobile radio right there. You can buy a package that includes the radio and the hotspot and that kind of thing. So bridgecomsystems.com. Check the link in the description below for them and for the other things we talked about today. So those are some good places to start if you're just getting into the hobby. Okay, Chris, how's it going? Back over there?
Back in action.
Back in action, okay.
Back in action.
Was that long enough for you?
Oh, yeah. Okay. Yeah. I just went ahead, disconnected, and then just to be safe, restarted my modem, and so all is well, hopefully. So,
good. Okay, man.
It's all ready yours. When you are. Okay.
It's all yours. Thanks a lot.
Mm-hmm. Okay, so we're going to start getting into some of the electronic side of things. But like I said, don't be afraid. This is it's not hard. We're going to go over everything and make sure that you have a good understanding of what's what. All right, so the electrical term for the force that causes electronic flow is voltage. I think most people are familiar with voltage because we use AA batteries and things like that, and that voltage is listed there. So voltage is going to be the actual, the push, the electron flow through different things. The instrument used to measure electric potential or electromotive force is called the voltmeter. This one here shows 5.03 volts. And another way that you can test that is to use a voltmeter on a little multimeter like that right there. You measure it in parallel with the circuit. So red and black, you'll touch that and it'll give you your voltage. So your voltage is the actual electronic push of electrons. These battery types are rechargeable. So a lot of you want to make sure when you get a handheld radio that's got a rechargeable battery, because you don't want to be putting alkalines in it. So these are rechargeable: nickel metal hydride, lithium ion, lead acid gel cell. All of these are rechargeable. Following are not rechargeable. Don't try to charge them because it could end up with bad results. Carbon, zinc, or alkaline. So we got the difference there in between the two. So the way that you multiply the watts per hour consumed by the equipment by the battery power rating to determine the length of time that the equipment can be powered. Take the how many watts it says it is, divide that by the time that you need to use it, or how long you expect to use it, and that'll let you know how long you'll be able to use the batteries. The negative return connection of a mobile transceiver power cable should be connected to the 12-volt battery chassis and ground. So that negative cable needs to have really good, solid connection. We're not even talking about amateur radio, just for your car in general, but that would be something to check, thoroughly if you have some sort of noise in your your radio as you're driving. Check your ground. That's a really good starting spot. So the name of the flow of electrons in electric circuit is its current. You will use an ammeter to measure the electric current. That electric current is measured in amps, or you may see on a battery, milliamps or amps or mega amps if you're talking about a lot of power. Metals are generally good conductors of electricity. They have many free, as they have many free electrons. The more free electrons there are, the better the conductor conducts. Some metals will conduct better. Um, Copper and aluminum are very good conductors, and so those could be used for power wires. Not only power wires, you can use them for antennas because the flow of electrons is very good. The current that alternates between positive and negative directions describes alternating current. So the stuff that you have in your wall, that is AC current. AC current. That's going to be um, basically what happens is as the power is coming out, the electricity comes out, and then it polarity flips, and then it'll flip again. So it'll do that 60 times a second. And so that is alternating current. And you'll use an ammeter connected to a circuit in series with a circuit to measure that current, shown here. If you look at this has got a little 6 amp lantern battery on there, and this will show you the voltage drop between different different components there. Keep wiring between power sources and the radio to heavy gauge wire and as short as possible. The shorter the better. And of course the thicker the better also. A short fat wire will have a lot less resistance than a long skinny one. So um, one of the things that you will get with a long skinny uh, power wire is you'll get a voltage drop, and also you'll get heat depending on how much power you're actually drawing. An appropriate power supply rating for a typical 50-watt output mobile FM transceiver is about 13.8 volts at 12 amps. That's a pretty good reference for mini mini radios at 50 watts. If you use lower power, you won't use that many amps, but you want to use cable that is rated at least what the radio says. Generally, they'll come with 12 gauge wire, 10 gauge wire, depending on how powerful they are. But you never want to use a smaller wire because it could actually heat up and cause a fire or something like that. So the device or circuit that changes alternating current into a varying direct current signal. So we take out the alternating and make that a direct current. It's called a rectifier is what it is. It's got diodes, combination of diodes, and what it does is it actually strips out half of the AC signal, making it a DC, a direct current signal. A diode it's like a check valve. It's a one-way component, so electrons will go through and they can't go back. It's essentially a check valve. What it is, if you look at this little graphic right here, it's got the arrow with the line right there. That line actually corresponds with that diode, that white stripe on that diode. That's what it'll look like on that type of diode. But it will tell you which way to put in a diode if you're going to be doing some sort of surface mounting type stuff. So looking at this is an AC source. You see that sine wave. The power is going positive, negative, positive, negative, positive, and so on and so on. If you add a diode in there, because you are stripping out the ability for that backflow to go negative, well, you're gonna have DC current. This is kind of dirty right here. It's not real clean, but that's what a diode will do. It will prevent that that backwards of any kind of current going backwards. Forward voltage drop in a diode is lower in some diode types than others. There's a lot of different kinds. I'm not even going to try and guess. There's a lot of different kinds of diodes, and so each one of them has a function, but their primary function is to put a check valve in the circuit. So the two electrodes of a diode are the anode and the cathode, positive and the negative. Positive coming in, cathode is the negative. Um, and so the cathode lead of the semiconductor is usually identified with a stripe. And if you look at like I said just a minute ago, if you look at um, the image there for a diode, it will correspond with that stripe, so you know which way to put it in there. An electrical component used to oppose the current in a DC circuit is the resistor. Resistors have different ratings, like how much resistance they can provide. If you look at these stripes, each stripe in combination with the next will give you the value of that that resistance. You can get a little chart and you can put the colors in there, and it will tell you exactly what that means. Um, or you can reference it somewhere else. But each one of them has four stripes, and will give you the value of that resistor itself. And it's basically opposes the current flow. We call that resistance. So types of current flow that's opposed by resistance: direct current, alternating current, RF current. All of these we will use. And this little graphic right here perfectly represents the three things together. Ohms are your resistance, voltage is the push, amperage is the worker. So you can see the voltage trying to push the amperage, but the ohms resistance is squeezing down the pipe, and it just can't get through there very easily. So that's a really good representation of what that is. The units of resistance is called ohms. You need to know this. A unit of resistance is referred to as ohms, and you will see it in technical documentation as ohms. Ohm is the fundamental unit of the electrical resistance. The component often used as an adjustable volume control is a potentiometer, also known as a variable resistor. So that's just another name of it. It's a variable resistor. It's called a potentiometer. The electrical parameter controlled by a potentiometer is resistance. That's you turn the volume up, resistance lowers, and the volume gets louder, and vice versa. So a potentiometer, like I said, is a variable resistor. Glass is a good electrical insulator. I don't know if you can see my picture here. I've actually got one of these glass insulators off of the railroad pole. Um, Glass is an extremely good electrical insulator. Um, these were up on top of the telephone poles there, insulating the wires from the I guess the beam or whatever you would call it. So it's a very good, as well as ceramic is another good one. And I think that's what's used now. So just keep that in mind. Glass is a wonderful insulator. Okay. One of the electrical components that I want to make sure that you understand is the inductor. So an inductor basically stores energy, but it doesn't, what it stores it as is a magnetic field, it's magnetic energy. Um, it's measured in the Henry. The Henry is what we call is what it's called that we actually gives us the value of the inductor. And the electrical component is usually composed of a coil wire. Sometimes it has a bar going through it, a metal iron bar. These are a couple variable and uh, the one on the left is not a variable. That's actually defined, and then the ones on the right are variable inductors. So what does it do? It stores energy in a magnetic field called inductance. So an inductor is it stores energy in a magnetic field called inductance. Um, the basic unit of inductance is what we call the Henry. So the Henry is what is the amount of magnetic energy that's being stored. Impedance is a measure of the opposition to AC current flow in a circuit. The basic unit of impedance is the ohm. So let me recap here. An inductor stores magnetic energy, and the reason I keep uh, really kind of emphasizing that is because it stores energy in a magnetic field called inductance, measured in the Henry, and then you have impedance, which is what you get from a resistor. And it is an ohm is how you measure that. Now, the reason I was emphasizing magnetic field is because we're going to add a little complexity to that. Um, the ability to store energy in an electric field. In an electric field compared to a magnetic field, it's called capacitance. And this is what we call a capacitor. So the basic unit of a capacitance is a farad. Now, these are just some examples. There's many different kinds of capacitors out there. We got ceramic, and we've got aluminum, and we've got variables, and just different kinds there. The electrical component that stores energy in a capacitor is it stores it in an electrical field. That's different than an inductor. An inductor does magnetic. A capacitor stores in an electric field. Now, why does that matter? Well, the way that it's built, it's kind of like a jelly roll. You have multiple layers separated with like metal plates, isolated from each other using paper or some kind of dielectric where it's isolating, so it stores that energy. The type of electrical component that consists of two or more conductive surfaces separated by an insulator is a capacitor. And again, that stores electrical energy compared to magnetic with an inductor. The electrical component used to protect other circuit components from current overload is the fuse. Let me go back here. They should have told you in this. Why do I keep emphasizing those two? Magnetic versus electric. You have inductance versus capacitance. Both of those are measured. What we measure is the Henry. So whenever you're measuring that, what you actually the value is the Henry, even though they're two different. One is doing one thing, one's doing another. They're both measured using the same value. The Henry basically is what it is. So we're going to talk a little bit about fuses. This is your safety net is basically what this is. It's an electrical component used to protect other circuit components from current overload. If you pull too much power from a wire and it is a fused wire, it will blow the fuse. that's a safety mechanism to keep the wire from actually catching on fire and setting your car on fire or your house or something like that. Fuses are found in almost everything in your household. The component that can be used as an electronic switch or amplifier is the transistor. There are many different kinds of transistors. Each one of them does kind of they all sort of work the same to do the same thing. So you can see here these are a list or just a little graphic of different ones. Each one of them, you can see the has its own diagram. Some are more complex than the other, depending on its type. So the names of the electrodes on a bipolar junction transistor, which is going to be, looking at this, is going to be that first large black one with the three prongs coming out the bottom. A bipolar junction transistor are the emitter, the base, and the collector. The term that describes the transistor's ability to amplify a signal is gain. So transistors are measured in gain when it comes to amplifying a signal. The transistor is an electronic component that can provide power gain. So you will oftentimes find these um, in the amplifier of a radio. You'll find them in there because they are able to amplify power, especially RF power, before it's transmitted. The component made from 3 layers of semiconductor material is the transistor. As I said, there's quite a few different ones, but essentially they all do the same thing. They either amplify or they are, to put it simply, on-off switches. That's the 2 functions that they do. These are 2 schematic versions of that, telling you what it is. If you look at the first one, NPN, you can look at the one of the sides of the N is actually yellow, or the green, red, green. I'm sorry. And then if you look at the second one right there, I'll tell you how you can distinguish between a NPN and a PNP. If you look at not only the actual icon there in the diagram, if you look at the arrow, it will tell you what kind of transistor it is. An NPN, that arrow is pointing outward, so it's not pointing in. I mean, that's how I learned it, and that's how it always has stuck with me. So NPN, not pointing in. The other one, the PNP, if you look, it's just the material is different. But then on the other one, the arrow is pointing in. Pointing in. I mean, it's again, it's that may be oversimplifying, but that's how I always remember it. Not pointing in or pointing in. Just to kind of help with identification there. The type of transistor with a gate, a drain, and a source is a field effect transistor, an FET, a FET. These are commonly used all the time in electronic components. So an FET, that's going to be your important thing there. And it has the gate, the drain, and the source, input, output, and basically positive, negative, positive and a couple of negatives. One of them could be a ground, depending on it's the way it's set up. Okay. Some questions about what we've just covered. What is the electrical term for the force that causes electron flow? Voltage, amp hours, capacitance, inductance. The flow of electrons is voltage. Which instrument would you use to measure electrical potential? Ammeter, voltmeter, wave meter, ohm meter. Electrical potential is measured in volts, so we're going to use a voltmeter. How is a voltmeter connected to a component to measure the applied voltage? Series, in parallel, in quadrature, or in phase? A voltmeter is going to be measured in parallel. Which of the following battery chemistries is rechargeable? Nickel metal hydride, lithium ion, lead acid, or all of these? All of these are common use rechargeables in amateur radio. We use these a lot. I mean, they're very, very common batteries for just about anything, but very common also in amateur radio. Which of the following battery types is not rechargeable? Nickel cadmium or NiCad, carbon zinc, lead acid, or lithium ion? This one is going to be carbon zinc. And if I remember right, I believe these are used in like hearing aids. So you don't want to try and charge those because you won't be able to, and it could cause issues. How can you determine the length of time that equipment can be powered from a battery? Divide the watt hour rating by the battery by the peak power consumption of the equipment. Divide the battery amp hour rating by the average current draw of the equipment. Multiply the watts per hour consumed by the equipment by the power rating, or multiply the square of the current rating of the battery by the input resistance of the equipment. It's not very complex, so you're just going to divide the amp hour rating by the average current draw. If you have a 2 amp battery and you have something that draws 100 milliamps, well, you'll get about 20 hours of usage out of that battery. Where should the negative power return of a mobile transceiver be connected in a vehicle? At the 12-volt battery chassis ground, at the antenna mount, to any metal part of the vehicle, or through the transceiver's mounting bracket. The negative power return of a mobile transceiver should be connected at the 12-volt battery chassis ground, if possible. There's a chance that you may not be able to get that far, so you can go to really any good clean like a screw connection. As long as it is a bare metal, you can use that. But the best way is go straight to the battery if possible. What is the name for the flow of electrons in an electric circuit? What is the name of the flow of electrons? Voltage, resistance, capacitance, or current? So the voltage is not it. It's the current. The current is the actual flow. The voltage is the push of the electrons. Current is the flow. Which instrument is used to measure electric current? Measure electric current. Excuse me. An ohmmeter, an electrometer, a voltmeter, or an ammeter. So if you're going to measure electric current or amperage, you need an ammeter. And most multimeters will have this setting on there. Electrical current is measured in which of the following units, excuse me, volts, watts, ohms, and amps. So we are talking about amperage because we're talking about the current. So why are metals generally good conductors of electricity? They have a high density. They have many free electrons. They have many free protons, or all of these are correct. The proper answer is going to be they have many free electrons. Some metals are better than others. Copper and aluminum are going to be your best, for antennas, and oftentimes you will find them made out of copper or aluminum, and then those will give your best performance. So which of the following describes alternating current? It's current that alternates between positive direction and zero, current that alternates between negative direction and zero, and then current that alternates between positive, negative directions, or all of these are correct. So this one you want to watch very carefully. Make sure that the first two What make those wrong is zero. It's actually positive and negative, not just positive and zero, positive, or vice versa. So it's positive and negative, positive back and forth. When configured to measure current, how is a multimeter connected to a component? Is it in series? Is it in parallel, in quadrature, or in phase? So when you're going to measure current, you will measure it in series. Where, well, I won't confuse this. So you measure it in series. Why are short, heavy gauge wires used for a transceiver's DC power connection? To minimize voltage drop when transmitting, to provide a good counterpoise for the antenna, to avoid RF interference, or all of these above. The reason we use short, heavy gauge wires because we want to minimize voltage drop. Your radio works best at a certain volume or excuse me, a certain voltage, and if you drop below that, you will lose efficiency. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? 24 volts at 4 amps, 13.8 volts at 4 amps, 24 at 24 amps, or 13.8 volts at 12 amps. It's going to be D. Now, when you go to select a power supply, you don't want to select one at 13.8 volts at 12 amps. You want a larger one. So you don't generally a good rule of thumb is you want to stay away from a piece of equipment's maximum. So if it is a power supply at 12 amps, well, that's the maximum. You want to stay away from that. So maybe 4, 5, 6, maybe even 24 amp. You can get 24 amps, so you double your extra safe there. Okay, so which of the following devices or circuits changes an alternating current into a varying direct current signal? Remember which one we talked about? Transformer, a rectifier, an amplifier, or a reflector? It's going to be a rectifier. That's the one that's going to be a combination of diodes to prevent the backflow. So it strips out half the AC and makes it a DC current. What electronic component allows current to flow in only one direction? Resistor, fuse, diode, or the driven element? It's going to be the diode. Think of it as a check valve, or check valve. Which is true about forward voltage drop in a diode? It's lower in some diodes than others. It's proportional to the peak inverse voltage. It indicates that the diode is defective or it has no impact on the voltage delivered at all, which is true about forward voltage drops in a diode. It's going to be, it is lower in some diode types than others. Just one of those questions you'll have to memorize because it's kind of an oddball there. What are the names of the two electrodes of a diode? Plus and minus, source and drain, anode and cathode, or gate and base. So we're talking about a diode, and the two electrodes are going to be the anode and the cathode. I know there's a lot of different a lot of different ones there, but those are for different pieces. So anode and cathode, negative and positive, are going to be what they are. How is a cathode lead of semiconductor diode often marked on the package? With the word cathode, with the stripe, with the letter C, or with the letter K? It's always going to be the simplest. It's going to be with a stripe, just a little stripe, white stripe, yellow stripe, something that differentiates, one side from the other. You will be able to tell the difference and which way the diode is supposed to go. What electrical component is used to oppose the flow of current in a DC circuit? An inductor, a resistor, an inverter, or a transformer? This one is opposing or restricting the flow of current. So that one's going to be a resistor. None of the other three have anything to do with restricting flow. So resistor is the answer. What type of current flow is opposed by resistance? Direct current, alternating current, RF current, or all of these are correct. The current flow as opposed by resistance is actually going to be all of them. So the answer is D. All the choices are correct. So what are the units of electrical resistance? The Siemens, the mhos, the ohms, or the coulombs? Resistance is always measured in ohms. So what type of component is used as an adjustable volume control? Discuss this: temporary, a fixed resistor, a power resistor, a potentiometer, or a transformer. This is also, and because it's adjustable, it's also known as a variable resistor, but we oftentimes just call it a potentiometer. What electrical parameter is controlled by a potentiometer? Inductance, resistance, capacitance, or field strength. Because it is a resistor or potentiometer, it's going to be measured in resistance. Which of the following is a good electrical insulator? Copper, glass, aluminum, or mercury? Well, the A, C, and D are all metals, which do very well. So glass, B, glass is going to be your very good insulator. What type of electrical component stores energy in a magnetic field? So think back why I kept emphasizing what is a magnetic field? What stores that? That's going to be your inductor. That's one thing that is going to you will actually see those. They're just little coils of wire, and they're storing energy in a magnetic field. What electrical component is usually composed of a coil of wire? Well, we just talked about that. That's going to be an inductor. Now, I know you won't see all of these questions will be randomized. You will get parts and pieces. So you won't see like the past two questions together. They will be split, you'll have different ones. So that's why you're seeing so many of these that are kind of one right after the next. What describes the ability to store energy in a magnetic field? What describes the ability? Admittance, capacitance, resistance, or inductance? So a magnetic field stored in an inductor is inductance. Okay. What is the basic unit of inductance, though? What do we measure that in? We're going to measure that in the Henry. So what is impedance? What is impedance? Is it the opposition to flow of AC current, inverse of resistance, the Q of quality factor of a component, or the power handling capability of a component? Impedance is going to be that restricted, that restricting down of the flow. That restricting is done by a resistor. So that's going to be what the answer is: the opposition to AC current flow. Um, none of the other questions there make any or answers make any sense. So you can look for the answer that is the one that makes the most sense. So like I said, like a lot of these other ones, we never even mentioned any of that other stuff. That's kind of a general and extra class thing, but they throw them in there just maybe to as answers. So we did cover the opposition to AC current flow, which was impedance. What is the unit of impedance? What did we say that was? The volt, amp, coulomb, or ohm? It's going to be ohm. Ohm. Dad joke, sorry. What describes the ability to store energy in an electric field? So we've already gone over magnetic field. Now we're talking about an electric field. What is that? Conductance or inductance, resistance, tolerance, or capacitance? The ability to store energy in electric fields, capacitance. What is the basic unit of capacitance? This is where I went back to make sure I said these two components, they do different things. They both store energy in different forms, but they're both married. They're both measured in the farad. So capacitance and inductance are both measured in the farad. What electrical component stores energy in an electric field? A varistor, capacitor, inductor, or diode. Electric field is going to be your capacitor. What type of electrical component consists of conductive surfaces separated by an insulator? This was the jelly donut reference that I gave. It's a metal with some sort of insulator, and it's rolled up or layered on top of it. This is going to be your capacitor, and that's how it stores that energy up, ready to be released all at once. What electrical component is used to protect other circuit components from current overloads? A fuse, a thyratron, a varactor, or all of these choices are correct? It'll be a fuse. Just a simple, humble little fuse that you pull too much power and it will pop and open that circuit. Which of these components can be used as an electronic switch? It's going to be an oscillator, a potentiometer, a transistor, or a voltmeter. So the function of a transistor is to be either an amplifier or an electronic switch. So what are the names of the electrodes of a bipolar junction transistor? Bipolar junction transistor. The names of the electrodes. Signal bias power, emitter, base collector, input, output, supply, pole 1, pole 2, and output. The only ones that we talked about in regarding your electrodes is the emitter, the base, and the collector there. So what is the term that describes a transistor's ability to amplify a signal? We went over this one just a minute ago. How is it? What is the term? Gain, forward resistance, forward voltage drop, or resistance? So a transistor, if it's functioning as some sort of an amplifier, it's going to be measured in gain. Which of the following can provide power gain? Transformer, transistor, reactor, or resistor? We've been talking about the transistor. Try to make sure that you identify things that you are familiar with. They're not going to sneak in a question that you're not familiar with. So this one we've been talking about the transistor, and we have talked about it. We haven't talked about a reactor. But power gain is a transistor. So which of the following components can consist of 3 regions of semiconductor material? Alternator, transistor, triode, or pentagrid converter? Well, my hesitation will automatically strike out D for you. It's going to be a transistor. This one has 3 regions. It's got the 3 poles on it. That's going to be the transistor, excuse me. So what type of transistor has a gate, a drain, and a source? This one had a specific name that we said. It's varistor field effect, Tesla effect, or bipolar junction. This one has the gate, the drain, and the source is called the field effect transistor. FET is what you might also see it referred to as. What does the abbreviation FET stand for? Would we just say that was that stand for? It's going to be D, field effect transistor. Okay, we are almost into the last section for tonight. We're doing better on time. And then if it's okay with you, Jason, once we're done with this, if there are any outstanding questions, might just take a couple of minutes. But we're doing really good on time and
Good.
making pretty good headway. So
Okay.
um,
Okay.
yeah. Yeah, we'll just go ahead and get through this last little bit and then do a Q&A if for anybody who might have questions.
Okay. Sounds good.
Cool. Okay. we're going to still be in a little bit of the electronic theory here. Um, so it's the law per Mr. Ohm. So power is the term that describes the rate at which electrical energy is used. That is, you know, pretty straightforward there. Electrical power is measured in watts. That's how we do it. You might hear from your electrical bill, you use 50 kilowatts or whatever. So electrical power is measured in watts. The formula used to calculate electrical power in a DC circuit is power, P, um, or excuse power. P equals voltage. E is multiplied by current. Now, I'm going to give you this little diagram. I'm going to really encourage you to write this down and study it. It's a little pie. It is basically what it is. Power equals voltage times current. Um, how this is going to be effective, I will show you in just a minute, but be sure to write that down because it will help you in answering some of these questions just because it's a visual representation. All right. So the power being used in a circuit when applied to a voltage is 13.8 volts DC, and the current is 10 amperes, is 10 amps. Solving for P is what we're trying to find out the power. So what we have the voltage, which is E, we have the amperage, which is I. So now we can actually just cover up the P or mark it out or put your thumb on it. And so now we can just say what is I times E, 13.8 volts times 10 amps. There we go. P equals I times E. 10 times 13.8 is going to give you 138 watts. So that's one method there, and it can be used for all of these little calculations here. The power being used in a circuit when applied to a voltage is 12 volts DC, and the current is 2.5 amps. Solving for P, so cover up the P and plug in the two other numbers. So 12 volts times 2.5 amps. That's going to be P equals I times E because we have the voltage and we have the current. 2.5 times 12, that's going to give us 30 watts. And you figure that out just because you covered up that P, because that's what we were looking for. The amount of current flowing in a circuit when the power is 120 watts and the applied voltage is 12 volts. So now we're trying to solve for I. So cover up the I because that's we're trying to find out how much current, and we're going to plug in the two numbers. So P divided by E. So 120 question marks 12. So 120 divided by 12. I guess it makes a little more sense if I actually put that on the screen. The question mark there, I don't know why that's there. But the actual answer is 10 amps. So P divided by E, 120 volts, 12 amps, or excuse me, the other way around, 120 watts and 12 volts will give you 10 amps. And we found that out just because we covered up the little letter there. So this formula, here's another one that you can use that I would also recommend that you write out. So there's only two of them there, so I'm not going to keep giving you more and more. But the function works the same way. EIR. This formula is used to calculate voltage in a circuit. Voltage equals current multiplied by resistance. So back to our little electricity explain, ohms, amps, and volts there about what each one of them is doing. The voltage across a 2 ohm resistor, if a current of 0.5 amps flows through it, is. So we need to know what the voltage is. So we take the E equals I. We have the resistance and the amperage, so we can plug these numbers in. E equals I R, 0.5 times 2 it's going to give you 1 volt. And we figured that out because we were trying to find voltage, so we just covered that one up, and then they're side by side, so that was multiplication. Just multiplied those two together. The voltage across a 10 ohm resistor, if a current of 1 amp flows through it. So we're trying to find voltage again, so we cover up E. So now it's E equals IR. So 1 amp across a 10 ohm resistor, E equals I times R. 1.0 times 10 is going to equal 10 volts. So I hope this is making sense. This is really designed to kind of help make things easier in calculating these numbers. The voltage across a 10 ohm resistor of a current is 2 amps. 10 ohm resistor current is 2 amps. So we're still looking for voltage. E equals IR. 2 amps, 10 ohms. That's going to be 20 volts. Y'all doing good. Keep going with me. Don't lose me yet. Okay. In a parallel circuit, the current at the junction of those components divides between them and is dependent on the value of the components. So the formula used to calculate current in a circuit is current equals voltage divided by resistance. Now here's I know this is the same one, that second one that we were using. This time we're going to plug the numbers in a little bit differently. All right, so current flowing through a 24 ohm resistor connected across 240 volts. We're looking for current, so we're going to cover up I. Now, we've covered up I, so I equals E divided by R, because E is over and separated by a line from R, so I equals E divided by R. Plug in the numbers. I equals 240 divided by 24, and that's going to give you 10 amps. So the current flowing through an 80 ohm resistor connected across 120 volts is, so we're still looking for current. We have 80 ohm resistor. That's going to go into the R. And we have voltage, so 120 volts divided by 80 is going to give you 1.5 amps. Couple more here before we move to the next one. Current flowing through a 100 ohm resistor connected across 200 volts. Cover up the I. I equals E divided by R. 200 divided by 100 is going to give you 2 amps. So it's not too hard. We're keeping this at a basic level here. So that's like I said, if you have these two little charts here, it'll go a long way. Now you can't have these, you won't see them on the test, but the very first thing that you can do is when you're taking your test, even if it's online, you can have a piece of paper and you can draw this out. But then you will have to show your examiners what it is, because it's all handwritten, and make sure that you're not cheating. So at the junction of two components in a series circuit, the current is the same on both components. We're going to add a little bit different here. So the formula used to calculate resistance in a circuit, resistance equals voltage divided by current. So we're going to start trying to find resistance here. The resistance of a circuit in which the current of 3 amps flows through a resistor connected to 90 volts. We want to know the resistance, so we're going to put a finger over it. So E divided by I. 90 divided by 3. That's going to give us 30 ohms. All right, and the resistance of a circuit in which the applied voltage is 12 volts and the current flow is 1.5 amps. Same thing we've been doing. We're covering up the R. We're going to take the values and we're just going to plug them in. E and I. Just make sure you have your E and your I's and your R's. Make sure you know those. And then you just just plug it in. Your resistance is going to be 8 ohms. So the resistance of a circuit that draws 4 amps from a 12-volt source, so same formula, 4 amps from a 12-volt source, so 12 divided by 4, going to give you 3 ohms. So our last little bit will just be some questions. Hopefully you got those, but as long as you can memorize those 2 charts or you have them written down, we'll get through these pretty quick and you'll get the right answers. So which term describes the rate at which electrical energy is used? Is that resistance? Is that current? Is that power? Is that voltage? Power is measured, the rate. How is that rate measured? Electrical power is measured in which of the following units? It's going to be volts, watts, watt hours, or amps. We measure them in watts. We don't generally say watt hours. That's assumed. That's just part of watt hours. Which of the following in TC? What is the formula used to calculate electrical power P in a DC circuit? Which one was that? If you were looking at that little chart, which one is it? It's going to be A. P equals I times E. If you look at this, you can almost you usually could strike out the subtraction and the addition. It's either going to be multiplication or division, depending on which one it is. How much power is delivered by a voltage of 13.8 volts DC and a current of 10 amps? So we're going to plug those in, and we will get 138 watts. So P and then 13.8. So once we get all that plugged in, 138 watts using those little charts there. How much power is delivered by a voltage of 12 volts DC and a current of 2.5 amps? 4.8, 30, 14.5, or 0.208 watts. I want to give you enough time to figure it out, but also we need to continue on here. So 30 watts is going to be the proper answer there. How much current is required to deliver 120 watts at a voltage of 12 volts DC? 0.1, 10, 12, or 132 amps? Answer is going to be 10 amps. So what formula is used to calculate voltage in a circuit? Voltage in a circuit equals I times R, equals I divided by R, equals I plus or minus R. Like I said, we can strike out the subtraction and the addition, and it leaves us with these two. The proper answer, E equals I times R. So what is the voltage across a 2 ohm resistor if a current of 0.5 amps flows through it? The voltage across a 2 ohm resistor if a current of 0.5 amps flows through it. Using our little chart there and a little bit of math, we should be able to come to 1 volt. And these are the actual, I'm pretty sure you'll recognize this. These are the actual questions on the question pool. So this is what it will look like. So this is why you will have to, I would recommend that you just kind of draw out those little charts, pie charts that we did. Let's see here. What is the voltage across a 10 ohm resistor if a current of 1 amp flows through it? Is it 1 volt, 10 volts, 11, or 9? 10 times 1 is going to give us 10 volts. So what is the voltage across a 10 ohm resistor if a current of 2 amps flows through it? Which one is that? 8.2, 12, or 20 volts? 10 times 2 is going to give you 20 volts. Okay. A little bit different here. In which type of circuit is voltage the same across all components? Which type of circuit? This was like a one question out of the blue sentence that we covered, and then we went right back in. So, which type of circuit is the voltage the same across all components? It's going to be parallel. Parallel is the answer. And just like the out of the blue question on the statement, we had an out of the blue question, and now we're back to our calculations here. So, what formula is used to calculate current in a circuit? So we're going to get rid of the plus and minus, and now we have to determine between A and B. You just have to memorize these. This answer is going to be I equals E divided by R. I equals E divided by R. Couple more calculations here. What is the current through a 24 ohm resistor connected across 240 volts? Current through a 24 ohm resistor connected across 200 volts. 24,000 amps, 24 kiloamps, that's a lot. 0.1 amps, 10 amps, or 216 amps. Well, it's going to be 2240 divided by 24 is going to give you 10. What is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? 9,600 amps, 200 amps, 0.667 or 667 milliamps is another way to look at that, or 1.5 amps. The current in a circuit applied voltage of 120 volts and a resistance of 80 ohms is going to be 1.5 amps. We're dividing in this case. What is the current through a 100 ohm resistor connected across 200 volts? 100 ohm resistor connected across 200 volts. So we're going to do 200 divided by 100, and that's going to give us 2 amps. So which type of circuit is DC current the same through all the components? DC current compared to the AC that we were talking about earlier. DC current is the same through all the components in series. AC was parallel, DC is series. And back to our formulas. What formula is used to calculate resistance in a circuit? Knock out C and D automatically. Is it going to be A or B? Multiply or divide in this case. This is a memorization thing that you'll just have to memorize. It's going to be divide. So R resistance equals voltage times, or excuse me, voltage divided by amperage. R equals E divided by I. Just a couple more. We're almost there. Y'all hang on with me. What is the resistance of a circuit in which a current of 3 amps flows when connected to 90 volts? So how are we going to figure this out? Is it 3 ohms, 30 ohms, 93, or 270? So we're going to take 90, divided it by 3. 90 divided by 3 is going to give you 30 ohms. What is the resistance of a circuit for which the applied voltage is 12 volts and the current flow is 1.5 amps? How do we figure this out? Is the answer 18, 0.125, 8, or 13.5 volts? In this case, it is going to be 8 ohms. And the resistance of a circuit that draws 4 amps from a 12-volt source. What's the answer? 3, 16, 48, or 8? So 12 volts, 4 amps, 12 divided by 4. It's going to give you 3 ohms. And with that, that is the end of session 2. I hope I didn't lose anybody when we started getting into all that math. So you made it. Congratulations for making it. Today was actually the most difficult. Electrical components and things like that are generally the things that scare most people. But this I think you probably did well as long as you were following along and taking the proper notes. So good job, everybody. And I'm good for Q&A. I've got a few minutes to spare if you want to.
Yeah,
If,
anybody who has a question specifically about anything that was gone over tonight, if you type the word question into the chat, of course there's not that many people watching right now, which is okay. We'll see it right now. I've got the chat pulled up. So if you do have a question, you're welcome to ask it now. If you are watching this later at some point in time, put a question in the comment of the YouTube video. As soon as YouTube processes this live stream, it will be replayable like everything else on this channel, and you'll be able to watch it as many times as you want to. So you can put a question or a comment in the comment section, and I watch those. I still get comments on the one we did 3 years ago because the question pool was good up until last year. Yeah. So Boinkmatic Gaming, which is a cool name. Thank you, Chris. I did learn something tonight from the pi calculation. I know now. So yeah, he mentioned that earlier as well.
Good.
So,
Good. Yeah, those are really, really helpful. That's how that's how I made it through my technician 20 something odd year, like numbers. However many years ago. I don't even remember.
Don't even know. Yeah.
But they're still the same. They don't change, and they'll help you out.
Yeah. Good. Okay. Is there a place to take the ham test online? Do we have to go to a building? So if you go to hamstudy.org/sessions, I'll type that link in the chat right now. hamstudy.org/sessions. It will show you testing locations that are virtual and online, and it will also show you testing sessions that are clicked on the wrong thing. Testing sessions that are local. Now, whoever's doing local testing has to report their information to hamstudy.org/sessions. You can look on ARRL. ARRL has a web page for testing locations and whatnot. If you can't find anything online, I would just Google whatever city or county you live in. Like, I live in the city of Grapevine, so I would Google Grapevine Amateur Radio Club, and I would find there's 5 or 6 clubs around me that I know for a fact gives testing sessions, so you can do it that way. What did Frank say? Oh.
How much wood could have... Blah, blah, blah.
Yeah, nothing important.
I saw that, and I was like...
Yeah.
Somebody really asking that?
That's Frank. That's Frank. So, yeah. Cool. But yeah, aa9pw.com is a good one for practice testing. You can take practice tests on qrz.com, what we call qrz.com. eham.net is another one. You can take practice tests all there. Oh, there's your wife. So she said hi to Frank. She didn't say hi to you or I. So,
Harry, Katie 5YZ is in the chat.
Yeah, yep. So, good. Well, thanks, man. This was good. Like I said, we'll reconvene tomorrow morning at 10 a.m. Texas time, which is 1500 UTC, and we'll do part 3, and that will conclude this session here. So
tomorrow is what I consider the fun. Antennas and stuff like that. I dig that. That's I find it a lot of fun. So that's what we're going to be. We'll be covering a lot of that tomorrow. So
cool. Yeah, the antenna section is fun. I enjoy that as well. So, good. All right, guys. Well, everyone have a good night.
Cool.
And Chris, thanks a lot, and we'll catch you in the morning.
Anytime. You bet.
See ya.
I'll be here.